Hello, Dr. Robin. I am Ming, and today I'm going to present you my personal contribution for this industrial automation final assessment. So I am part of Group 1 and I am in charge of the hardware with Jiquan, and my main contribution for this assignment is to select suitable components for Group 1 and Group 2 and constructing the station from scratch, improve of components designed by other team members, create schematic diagram for the team members to understand about the hardware for station 1 and 2, and lastly the analysis of the structure using stress, strain and displacement. So sir, you must be wondering why we are uh, doing for station 1 and 2 is because of station 1 and 2 is actually a full station and station 2 is in the middle of station 1. So this is why both teams have to work together, 16 people, to make this happen. So firstly, as a hardware member, we have to select the suitable components. So 30 times 30 profile is selected and also 30 times 30 bracket to suit it for the structure. So for the hardware members, we have to select the suitable fasteners. So we started from M4 screw, which is not really that suitable because of there are limited parts which we couldn't find, and it will take time to order from China. So this is why we selected M5 screw with the half round nut. So this half round nut is a really special one. It's because of half round nut, it consists of the ball bearing right here, which it is with a spring, so it can directly fit into the 30 times 30 profile. So we bought one is the one half round nut for M5 with which can fit 30 times 30 profile. So it will fit perfectly and hold the parts in place. So the station must be constructed from the scratch. So station 1 and 2 will work together in order to make this happen. So as seen in the pictures there, we have to construct it, we have to cut the profile and construct it. And after that, we will have to align it because of if the alignment is off, everything uh, uh, will be crooked. So this is why alignment is really important for the hardware, and the profile and so on must be selected correctly. So as I mentioned, I must improve the components designed by other team members. So this is also part of the station 1, which is the cutting. So this cutting station, uh, there will be a 3D printed part which is to hold the pen knife to cut the paper strip at the end of the station. So this 3D printed part must be done. So from the first design, which is this one, it have only one hole to hold the pen knife. So it is really unstable. So we proceed with the next design, which we have a fixed hole. But with the fixed hole, we doesn't know where is the suitable position for the hole to be. This is why it came up with the design tree. This design tree right here is requested in order for uh, the penknife to fix properly, like we can adjust it. Then after adjusting and the measurement is done, then the last one, the final one is constructed. So as seen right here, the final design is smaller, more compact, and can directly cut the strip into half. So as a hardware member, we also have to open up the hole in order for the penknife to go through. So after completing all of this, and the other group members who complete their respective portion, the whole station is completed as shown in the picture right here. So as a hardware member, we have to create a schematic diagram in order for all the members who participated but in their own respective role to understand the whole system. This is why the schematic diagram is needed. So as seen from the picture, we have uh, 8 IR sensors. So 6 IR sensors are for optical encoder plate IR sensor, which is for the turntable. Then one is for the input and one is for the cutter. So as we know, IR sensor can support up to 12 volt, but the recommended is 5 volt. Uh, this is why we supply 5 volt instead of 12, because 12 is actually not suitable. And the PLC we use is the PLC 1215 AC/DC relay. This PLC will have to receive 24 volt input. This is why we use 8 relays, because there are 8 IR sensors which we will use the signal to trigger the 5 volt relay to send the signal to the PLC. So the input for the PLC will be from the wall, which is 240 volt. So we will also have two buttons, one for start, one for stop, and there will be one limit switch for the SIS. And this start or stop button will have two outputs. So it will be shown the green and red LED. So green means the process is running, red means the process is not running. So the buttons will be used, one to start, one to stop. And there are few more outputs. So the first output that is needed is the motor. So the motor driver we use is L298N, which we will supply 9 volt to the motor driver, and it will power two power window motor. So these two power window motor, one is for the optical encoder plate and one is for the to push it from the stamping station to the cutting station. So after that we will have the cutter and the stamper. We'll use a 5 two-way solenoid valve. We'll use two of it to power two double acting cylinder. So this is pneumatic. That's why we need the compressor. So this summarizes the whole schematic diagram, and it is easily understandable with the labels and so on. So the last step is the structure analysis. So we have to analyze if the structure it can withstand the pressure and so on or not. So the force which is acting on it is 45 Newton, which is the weight of the cutting station. So this part is actually from a cutting station. We analyze I pick one of it to analyze as it will be more accurate. So this part as seen from the first picture is the strain. The second picture is the displacement, while the last picture is the stress. So in SolidWorks, no matter how low or high the stress, strain, and displacement is, it will still be shown deformed. So we just have to see the colors. So from the strain there, the colors are in acceptable range. Then, but for the displacement, because this is set as the aluminum profile, but aluminum profile won't displace that much, but it is shown like that is because um, the force is distributed uh, in the middle. This is the limitation of the SolidWorks. And the last one is the stress. So as seen right here, it is also in the acceptable range. So we have to improve it because every structure will have to be improved in future, because if we can use less parts means the cost will be lesser, and if it will produce a better result, it is also one of the most ideal things to happen. So for here, I remove the profile from the bottom here, right here, and as seen from this picture and this picture, it have a higher value, which is not ideal. But for this, the most important one is the stress. The stress, it doesn't look much different, which is really ideal, because to reduce the cost and to remain it inside the safety factor is really important. So now we will do the individual in individual leg for the structure. So as seen from the first picture, we know is the strain. So we have four legs, but this one is on individual legs. That's why it will bend even more. So as seen on the pictures, all of it are in acceptable range, which is really ideal, because the worst one is the displacement. We will have a little bit of rate, but if it is distributed evenly, it will be much better. So this one is the improved structure. So the only difference is I added one more bracket. So one more bracket down here will make the base more stable. If you make one of it more stable, then there are four of it, it will be really stable, and it will handle all the force and maintain inside the safety factor. But this will also increase the cost, but the cost won't be increased a lot. Is because of that we have to only add four more brackets, which is a really small cost to achieve that. So that's all for my personal contribution for this um, industrial automation assignment. So thank you, Dr. Robin. That's all for my presentation.